Okay, so pH, we're going to just introduce it at a very basic level right now. This becomes very important, especially in PHYL 142. And if you're going to any sort of medicine, pharmacology, or nursing, you definitely need to know pH. But what is pH? It's a scale used to measure the amount of protons in a solution. So basically the concentration of it. And remember from our atomic structure, protons are the same as hydrogen ions, as the same as H and H+. And why is that? Again, to review, here we have a hydrogen ion that somehow has an equal amount of all of the subatomic particles. So one proton, one electron. But if you have a hydrogen ion, what happens? Well, a hydrogen ion is going to have an unequal amount of electrons and protons. The most common hydrogen ion and most physiologically relevant one is H+. So you don't have an electron. And remember, in our universe, most hydrogen does not have a neutron. So what are you left with? If you have a hydrogen ion, you have a naked proton. So again, this is why H+ is the same thing as protons, or if you're listening to my lectures or anybody else's lectures, you often see that protons and H+ are sometimes used interchangeably. And so what about acids? So here we have hydrochloric acid, and the chemical formula for that is HCl. And here we have carbonic acid, and so we have a carbon here and also oxygen molecules and another hydrogen. And here we have a more complex citric acid. So these are all types of acids. But what happens when these are all water soluble, but what happens when you throw them into water? Well, the thing is that when you dissolve them in water, is that these hydrogen ions pop off of the original structure. So what happens is that you're actually releasing protons into the solution when you take any of these acids and throw them in water. Now the pH scale, well, what does that do? So the pH scale actually measures what's the concentration? So how many of these protons do you have packed into a certain volume of this solution? So what we notice is that this is where pH is kind of tricky. The lower the pH, the more protons you have in that solution. The higher the pH, the fewer protons you have in that solution. So the common misconception is that a neutral pH, so 7 is a neutral pH, but it doesn't mean that you don't have any hydrogen altogether. It's actually saying relative to pure water, you have that amount of hydrogen ions in that solution. So 10 to the negative 7 concentration of hydrogen ions. So again, neutral does not mean you don't have any protons altogether. It just means you have this certain reference amount of, or a certain level and concentration of protons. So when you go to the acidic side, what happens? Well, notice that the pH drops. So the lower the pH, the more concentration of protons you have compared to a neutral solution. And notice that this is exponents of 10 to the negative 6, 5, 4, 3, 2, 1. So it actually involves exponents. So every time you change one pH, a pH that has a solution that has a pH of 6 actually has 10 times the protons as a solution that has a pH of 7. And let's see, so here on the opposite side, well, now that you notice that as you get more basic and alkaline, the pH goes up. So this is where it's kind of counterintuitive. The higher the pH, the less protons you have. And so here we have neutral. So when you go from pH of 7 to 8, so the pH of 8 actually has 1/10 of the proton concentration as a solution that has a pH of 7. And notice that blood is slightly basic, so that's what we have here. Now how we determine pH, I'll try to end on this part. It involves logarithms, and this little negative sign over here is why pH is kind of counterintuitive at first. I'm not going to ask you to do logarithms on the test and in this class because it's not algebra 2. But if you really want to know why pH is that way, it's due to this. So this negative sign and the logarithms, this is why pH has that kind of inverse. Like the more concentrated solution is with protons, this is why the pH gets smaller and smaller. So lower pH, the more hydrogen protons in solution, and the more protons in solution, the more acidic the solution. So again, this is, if you're first learning this for the first time, it often confuses a lot of people. But once you kind of get it in your head that, okay, pH is like, the lower the pH number, the more protons you have, then you're pretty much set.